You might ask yourself, what are quantum dots? Well, quantum dots, or semiconductor nanocrystals, are semiconductor particles that are a few nanometers in size with optical and electronic properties. Whoa, that is a lot to digest. Let's start at the beginning, starting with semiconductors. We've always heard about semiconductors, but what are semiconductors? Semiconductors are a type of solid material that has a certain level of electrical conductivity between conductors and insulators. These semiconducting materials can also be found in groups 3A through 5A of the periodic table, consisting of aluminum, silicon, germanium, and so on. Semiconductors typically have a reduced resistance to the movement of an electrical current due to the presence of charge carriers like electrons and holes, making them ideal components in electronic circuits. This type of behavior is most common for diodes due to the depletion region within that acts as a barrier towards the charge flow. The depletion region is the effect of the combination of these charge carriers from the p-type and n-type junctions of the device. We normally don't see semiconductors because they make up the inner working components within our devices. Some of these semiconductor devices include resistors, capacitors, integrated circuits, op-amps, and even LEDs. In 1782, Alessandro Volta used the term semiconducting to describe the electrical properties of certain materials that could transfer electrical charges and then differentiating them from non-electric materials. In 1833, Michael Faraday created the first documentation on the observation of the semiconductor effect. He noticed that the resistance of silver sulfide decreased with temperature, which was different than what was observed with other metals. I mentioned that semiconductors can have both optical and electrical properties, but how can this be? Both of these properties can be determined by the band gap energy in semiconductors. For semiconductors, the band gap is small, allowing some electrons to jump from the valence band, where the electrons are not free to move and tightly bound, to the conduction band, where they are free to move and no longer bound, under certain conditions. The band gap energy also assists in determining the material composition of a semiconductor. The amount of light absorbed by a semiconductor, or the absorption coefficient, is related to the band gap energy, which connects these two properties. Now that we have some background information needed, the question still stands: what are quantum dots? Quantum dots, which are also known as semiconductor nanocrystals, are used to make up a number of elements or compounds such as silicon, cadmium selenide, and cadmium sulfide. Quantum dots range from 2 to 10 nanometers in diameter. The amount of energy released from these dots are relatively constant from electron to electron. This energy yields an emission of a single color that is entirely dependent on the size of the quantum dot, where the smaller dots emit a bluer color and the larger dots emit a redder color. This all is a property that is referred to as quantum confinement. As of right now, quantum dots are being used in biological medical research, solar panels, televisions, and even solid-state lighting. If this isn't interesting enough for you, check out this cool video from UBQD.
I walked into Dr. Patrick's office and he gave me a tour of the lab, and he turned the lights off and he shined the laser at this chemical beaker that had some solution that was stirring in it, and it lit up and it glowed this amazing orange color. And I was like, oh, these are quantum dots.
Quantum dot is a vanishingly small piece of semiconductor. It's 10,000 times smaller than the width of a human hair. And what they're used for is to efficiently change one color of light to another.
And if you put it between two panes of glass, you can make a window, and this can be used to generate electricity.
So the patent that we are licensing from Western Washington is solar window technology, being able to use quantum dots to allow skyscrapers to power themselves, to generate electricities in urban areas that don't rely on fossil fuels.
I hope this video helps pique your interest in quantum dots. It's still fairly new and ready to be explored. Thank you.